This is the Hurricane Center podcast, made possible by USAA, the South Padre Island Convention and Tourist Bureau, Live View, and the Texas Weather Network.
Hello, everybody. Welcome to NTWC Plus. It is good to see you today. We have everybody back today. Everybody's here. So I think we got a great program for you. And coming up in just a couple of minutes, we're going to hear from the great Dr. Phil Klotzbach. We'll get to him in just a moment. Always glad to have Dr. Phil on with us. But let's start by introducing, let's see, where do we go first? Bill Reed, you're on a tropical island of Aruba or somewhere it looks like. Bill, good morning.
Good morning, Tim and Hal and Phil and Alex and anybody who's watching. I'm up in New Mexico at our place now. The dew point's about 25, so it's very different than where Hurricane Hal is roosting right now, where it's pretty close to 80 in there. And I have to go away from home to get a tropical event down there, I guess.
That's all it took, and Hal, you're right. Hurricane Hal, Dr. Hal Needham, is somewhere awfully close to the first tropical storm of the season. Hal, dew point there is not 25, is it?
No, it's been in the upper 70s to around 80. It's been incredibly moist. I'm here in Galveston. Actually, it's a home game for me. I live in Galveston, and pretty amazing conditions. If I can turn the camera right here, this is the Galveston seawall right now. The Gulf is responding to these strong gusts in the wind field offshore, and you can see a lot of agitated water running right up to the Galveston seawall. Not a big storm surge, but enough to run up the beach. But the big concern here is the heavy rainfall flooding.
For those who are joining us, not as we're live, of course, but we're recording this on June the 17th, the day that the very first tropical storm of the season has shown up as of this recording. And Bill, why don't you give us an update on what's happening in the tropics and how you can tell us a little bit more about what you're seeing, and then we'll get to Dr. Phil. So, Bill, tell us what we're seeing out there today.
Fantastic. Let me share the screen here and take the suspense out. I'm sure was a lot of heavy work going on in the last few hours at NHC, deciding whether to put a name on this or not. But the conditions, weather conditions that I'll show you, or even though it's not a well-structured storm, the impacts, which are important, are exactly what you'd expect from a tropical storm. So we now have Arthur. It's just east of Matagorda Bay and hugging the coastline. It'll go right over Hal and mine's house. Instead of an eye passage, we'll just simply have the end of the rain and breaks in the clouds, and the wind will go away in there. And then the worst conditions will spread east. The indications still are it'll rapidly disintegrate after landfall between the shear and land. But I think they'll still have the impacts, especially some high water on the really low beaches of southwest Louisiana and the Bolivar Peninsula. As far as how it looks on satellite, as you can, the Houston area is here, Matagorda Bay is down here, and as you can see from the satellite picture, most of the intense weather is way out in the Gulf. But there was this little cluster formed northeast of the center overnight or early morning hours after midnight, and it's been very proficient at producing rainfall. And there's pretty good divergence going on between the jet stream to the north and the circulation of what is now Arthur. But this really caught my eye. These are surface plots. This is a platform offshore of Galveston. They've had peak gust of 69, and they're currently reporting that with 52 mile an hour sustained. It's up fairly high. This is nonsense. It says it's at 1,089 feet. I beg to differ. Maybe 100, maybe 100. That's about as high as those go. But this is on the southwest tip of the Bolivar Peninsula. They're sustained and gusting in the tropical storm. This is Shoals Field, a little bit in from the coast, but they're still getting the tropical storm force winds. And up close to where I live, it's windy, but nothing to, it just shows you how fast winds drop off when you lose the marine environment in there. Rainfall has been the advertised main event for this, and come on, work. This happened overnight. This all started around 3 in the morning. This pink and purple area there is all in the 6 to 8 inch range. Down here in Brazoria County, near Freeport up through Angleton in there. Harris, where the heavy population is, 2 to 4 inches, and isolated pockets of 5 inches have occurred with that. And that's on an area that had another 3 to 5 inches chalked up over the week. So usually it takes about 3 to 5 inches just to get nuisance flooding. But I think with the saturated ground and high bayous, there's going to be some flooding issues from that. With the tides up, the bayous don't drain quite as fast. The tides, I'll take a look at where it's probably the highest in there. Okay. 4 feet puts a lot of water on the Bolivar Peninsula. Some of it reaches the main highway that goes across the island. It's very flat land there where some places 4 feet is high elevation down there, but it's running 2 feet above normal, which is right in the wheelhouse of what was forecast by NHC. Let's see. Pull this down. What else do I got? Okay, Hal, what else do you have as far as impacts before I go to the quick broad view and toss it back to Phil?
Yeah, great question, Bill. Impacts were interesting with this system. The big impacts really were the heavy rain. And I think what really was challenging to communicate were 2 things. Number one, the rain was very localized. So yesterday, west end of Galveston Island picked up about 4 inches. You get over to Surfside, Brazoria County, Freeport areas overnight picked up 4.5 to 6 inches. But then people in Galveston City, 30 miles away, said, hey, this was just clickbait. This is a hyped up storm. Nothing happened. We only got about 1 inch of rain. So the localized nature of the flooding was one of the challenges to communicate. And secondly, and we've seen this before with tropical systems, you'll get torrential rain move through, and then you'll have 9, 12, 15 hours that are mostly rain free before the next round comes through. It's a multi-day flood event, and that's been challenging to communicate with people that this is really going to be rounds of heavy rain. And so the impacts that I've seen really were mostly from heavy rainfall in southeast Texas. I'm here on the Galveston seawall. We're seeing a lot of white water running up to the dunes. But like you said, Bill, I think we could see the lowest coastal roads have some washover, but I'm not expecting storm surge in any homes or businesses. This will really be a primarily rainfall flood event.
That's right. We get males driving pickup trucks are most at risk because they think they can drive through this water.
No, for sure. And we, got to watch out for that localized rain. Stay tuned to weather.gov. Obviously, the National Weather Service is doing a great job keeping those real-time watches and warnings.
Okay. Well, thanks, Hal. If you'll stop, if I'll go share, I'll show you the last tidbit of information before we get Phil going here. And it segues nice into it. After we get rid of Arthur, the systems calm down. None of the ensemble models that become very popular for driving hints of longer range outlooks beyond 7 days are showing anything of consequence developing, with a possible exception. So I've heard some chatter about when Arthur's remnants come back offshore, models have a strong low forming, but it's an incredibly high shear. I think it's interacting with the frontal system, and it'll be maybe a hybrid, but it'll be mostly an extratropical low, causing gale to maybe even storm force winds later this week. And with that, our guest is Dr. Phil Klotzbach, coming from just up the road from where I am in Colorado. And he's not worried about the short-term stuff. He's going to tell us all about his latest and greatest on what's going to happen the rest of the season. Good morning, Phil.
Good morning. Good morning, Bill. Good morning, Tim, Alex, Hal, all of you listening online. And so we're going to discuss the outlook for the 2026 Atlantic hurricane season. We just did officially get underway on June the 1st, and obviously we have our first named storm just a few minutes ago. So right on schedule. I believe today is the 17th. The first named storm on average forms on the 20th of June. So right on schedule. But, this hurricane seasonal outlook is a little bit different from ones we've issued in recent years. Unlike forecast for the last few years where the activity has been for well above normal. This year, we're actually forecasting a somewhat below normal hurricane season. A total of 11 named storms, so we already have one, so 10 additional named storms. So a named storm is any tropical storm or hurricane, anything named by the National Hurricane Center. Of those 11 named storms, 5 becoming hurricanes, and of those 5, 2 becoming major Category 3, 4, 5 hurricanes. Hurricanes with winds of 111 miles per hour or greater. We also forecast a couple of these integrated metrics, one of which is accumulated cyclone energy. This metric weighs strong, long-lived major hurricanes quite strongly, whereas weak, short-lived storms generate very low levels of ACE. So, for example, Arthur, which is probably going to only be around for a day or so, will generate very low levels of ACE because it's a weak tropical storm for a day, whereas intense, long-lived major hurricanes, such as Hurricane Melissa last year, generate large quantities of ACE. So if you're a baseball fan, you can think of it as kind of the slugging percentage of hurricanes. I'll be sprinkling in quite a few baseball references throughout this presentation, so apologies if you're not a baseball fan, but I'll try to tie some other analogies as well. They won't all be baseball related. Before we dive into why we're forecasting a below normal hurricane season, I wanted to talk a little bit about the philosophy behind seasonal hurricane forecasting. And so a lot of people think it's like this. This is my mentor, Dr. Bill Gray, the founder of the seasonal forecast, looking into his crystal ball and saying, verily, I see 17 named storms. That's not how we do these seasonal forecasts. It's not like my meteorological namesake, the groundhog, Punxsutawney Phil, waking up in the morning looking to see if we can see our shadow. We use a lot of historical weather and climate data to come up with these seasonal forecasts. So effectively what we're looking at are precursor signals. What sets of climate conditions precede active seasons, and alternatively, what sets of climate conditions precede inactive hurricane seasons. So it can be summarized in 2 quotes from the legendary New York Yankees catcher Yogi Berra. Once was, it's tough to make predictions, especially about the future. And whether you're forecasting sporting events, political results, hurricane activity, forecasting the future is extremely difficult. But there is another statement from Yogi that is really relevant when it comes to seasonal prediction, and that is that you can see a lot by looking. Basically, by going back into the past and looking at historical weather and climate data, it can teach us a tremendous amount about how active the upcoming hurricane season is likely to be. So if you've been following the news, there's been a lot of talk about El Nino. We officially have El Nino, and there's a lot of talk about it being a strong, or even what some people call a super El Nino. What does that portend for the Atlantic hurricane season? And that's really how these seasonal hurricane forecasts got started in the first place. My mentor, Dr. Gray, was teaching tropical meteorology in the early 1980s, and he was a fount of knowledge. Basically, he knew a lot of historical weather data. So he knew which years in the past had El Nino conditions. He knew which years in the past were busy hurricane seasons. And he said, hey, when we have busy hurricane seasons, we don't tend to have El Nino conditions. So when you have El Nino, the Atlantic hurricane season tends to be quiet. So first of all, El Nino is warmer than normal waters in the eastern and central tropical Pacific Ocean. La Nina is basically the opposite, colder than normal waters in the same region. And so, it's a little bit perplexing, right? Like, why would something going on in the Pacific Ocean impact hurricanes in the Atlantic Ocean thousands of miles away? And basically, it's through what we call teleconnections, or effectively when you change wind patterns, pressure patterns, water temperature patterns in one place, it then changes weather patterns throughout the globe. So for a nice schematic that Noah's put together really highlights this, typically your strongest thunderstorms in the Pacific Ocean tend to be near Indonesia, where the waters are the warmest. And in El Nino, as those warm waters shift eastward, those strong thunderstorms shift eastward in response. In thunderstorms, your low-level winds flow into those thunderstorms. The air goes up into thunderstorms in those big cumulonimbus clouds, and then high up in the atmosphere, those winds then diverge and spread out. So if we look at what goes on in the Atlantic Ocean during an El Nino, you tend to get more sinking motion. Sinking motion is detrimental for hurricanes because it tends to promote dry air and reduce the likelihood of strong thunderstorms that are the building blocks of the hurricanes. But more importantly, El Nino tends to really increase winds out of the east at low levels in the atmosphere and out of the west at upper levels in the atmosphere. And that increases levels of what we call vertical wind shear. So vertical wind shear is a change in wind speed and direction with height in the atmosphere. Too much shear is good for us, bad for the hurricane. It tends to tilt the hurricane circulation, disrupts it. You get more dry air entrainment mixing into the storm. Basically all things that hurricanes don't want. So typically in the Atlantic, your low-level winds near the ocean surface blow out of the east. At upper levels, they blow out of the west. So in a vertical cross section, you have vertical wind shear. So there's change in wind speed and direction with height in the atmosphere. El Nino tends to exacerbate that shear by increasing the low level easterlies, increasing the upper level westerlies, and that really increases the shear. And this signal is very strong in the Caribbean and across the tropical Atlantic. That's where we tend to see the strongest signals for increases in levels of vertical wind shear. Now, we use a lot of other predictors as well. This is just a simple composite. So this is the way Bill Gray used to say, if you're going to try to look for signals, this is a good place to start. So basically, we take the 10 busiest hurricane seasons since 1950, difference them from the 10 quietest seasons since 1950, and look and see what the water temperature patterns are. And so obviously, if there was map was all white, basically that would say, hey, there's no way to predict how busy the upcoming season is likely to be. But we do see coherent patterns in water temperatures. You see a La Nina signal. So La Nina tends to reduce your Atlantic shear, make for busier seasons. You also see a warmer Atlantic. Makes sense since hurricanes are basically their fuel source is warm ocean water. So more of that warm ocean water provides more fuel for the developing hurricanes. It also tends to be associated with lower pressures, a more unstable atmosphere, more vertical motion, so more motion going up in the atmosphere, all of which promotes a busier hurricane season. And so we look at June and July because this is when our skill tends to be the highest. And also, even though June and July is part of the hurricane season, typically about 95% of your category 3, 4, 5 hurricanes occur after the 1st of August historically. So this is a way just to kind of look at the skill of these seasonal forecasts. It's the start of year number 43 at CSU of issuing these forecasts. And so there's a variety of different ways you can kind of look at the skill, but this is just a very simple one, looking at correlations between the predicted and the observed number of hurricanes. So higher numbers indicate improved skill. So one thing you will note is that the columns get higher from April to June to August. Makes sense since we're closer to the events that we're trying to predict. We have more confidence in what El Nino looks like. We have more confidence in what the Atlantic Ocean looks like. We also have more confidence, say, in like what the conditions are over Africa, which is important because the seeds or the African easterly waves are basically strong thunderstorm complexes that frequently serve as seeds for Atlantic hurricanes, develop over Africa. In addition, you will note that the red columns are higher than the blue columns, which indicates improved skill in recent years. And that's good news. Obviously, we want to be doing better at our job. There's a couple of reasons for that. One is that the historical data with which we build our models has gotten better. And that sounds kind of funny, right? Like, how do we know now better what happened in 1990 now than we did in, say, 1995? And the reason is we have better models that basically can do a more sophisticated approach to taking the observations that we had, accounting for the uncertainties in those observations, and getting a more realistic view of kind of what the globe looked like. So we call these reanalysis products. So they take into account observations from the ocean surface, observations from the land surface, or you're taking in data from satellites, from ships, from land stations as well. In addition, one other thing that we have now that we didn't have certainly in the 80s and 90s is climate models. And so here we're looking for our forecast, say, for 1 to 3 to maybe as far as 6 months into the future. And we're not, say, looking for a forecast for August the 3rd. What we're looking for is, say, a 1 to 3 month average forecast of things like vertical wind shear, as well as things like surface pressures and water temperatures. And the models can do a reasonably good job at forecasting this, especially in the deep tropics. So obviously we don't, we're not going to say that every single forecast is going to be perfect, but overall the skill has improved, and we obviously hope to continue to improve the forecast skill. And we'll talk about some new tools, even that we've debuted with the 2026 hurricane season. But diving into 2026, the big reason why our forecast and pretty much everybody doing the seasonal forecasts is forecasting a below normal hurricane season is because of El Nino. So as you remember, El Nino increases your shear. NOAA just declared that, or the National Oceanic and Atmospheric Administration, otherwise known as NOAA, recently declared that we have an El Nino. You can see a lot of warmth in the Pacific. That blue rectangle denotes the region that NOAA uses to monitor El Nino and La Nina. The red rectangle denotes the Atlantic's main development region. You just kind of eyeball water temperatures across that red rectangle. You would say, hey, it kind of looks unremarkable, right? Like you want your MRI results to be, there's not much going on there. It's pretty close to average overall. Right now, the Atlantic is not looking super conducive, and the Pacific is certainly looking non-conducive for Atlantic hurricanes. So zooming in on the Pacific Ocean, we certainly do see a very robust El Nino-like pattern developing right now.
Seem to have lost your audio there, Phil.
Phil, your audio's dropped out.
Water temperatures just in this box alone. Whereas now it's declared as water temperatures in that blue rectangle minus the rest of the tropics. So since the tropics right now, if we step back to this previous slide, is somewhat warmer than normal, water temperature, or the new index that they're using, is running a little bit cooler than it would if we just looked at water temperatures in that box. So keep that in mind when you're hearing discussions about the current El Nino event. But we certainly have a lot of fuel for this El Nino to work off of. This is looking at upper ocean heat content. So this is looking at, instead of just water temperatures at the surface, we're looking at water temperatures in the top 300 meters or about 1,000 feet of the ocean. There's a lot of fuel for this El Nino to work off of. So, it certainly looks very likely that we're going to be headed up to quite a robust El Nino event. There's a lot of different forecasts for El Nino out there. This is a forecast from the European Center for Medium Range Weather Forecasting model, or the ECMWF, sometimes called the Euro model. And you might be wondering what the heck these strands of things that look like spaghetti are. This is basically an ensemble forecast. So starting on June 1st, the European Center model basically took all the observations that it had, puts in small little errors in those observations, because we know every single buoy, every single land observation, ship observation has small errors in it, right? Like the measurement estimates are not perfect. So you basically put small error estimates in those measurements, and then those very small errors grow with time. But you can see that every single of the 51 forecasts, what we call forecast members or forecasts that it ran, all are calling for strong El Nino, with about 2/3 calling for an extremely powerful event, higher than 2.5 degrees Celsius, what I would argue is a Jurassic El Nino event, because it's going to be so warm. This is what ChatGPT says a Jurassic El Nino should look like. So if I think we should really try to produce this movie. We'll just see if The Rock has availability, because it certainly looks like the kind of movie The Rock should be starring in. NOAA just put out their updated outlook, and we focus a lot on August through October because those are the peak 3 months of the hurricane season. About 90% of your hurricane activity in the Atlantic occurs during these 3 months. There's now a 69% chance for a strong or very strong El Nino event for August through October. And so obviously the big question is, what does this mean for the Atlantic hurricane season? And so there's a variety of different ways that we can kind of quantify this. This is simply looking at activity across the Atlantic basin. So this is looking at storms forming in the Atlantic, and you'll see that there are a lot more in La Nina relative to El Nino. But if you look at the ratios or the differences between La Nina and El Nino, you see that the ratios are stronger for, say, major hurricanes than they are for named storms. And I think Arthur perfectly makes this point, right? Like, it's a pretty highly sheared storm, not a very classic looking storm. It's going to be quite weak, but it still counts as a storm, right? So those can form kind of in any environment, like pretty marginal environments. Whereas to get a major hurricane, you need a pretty large area of conducive conditions. And not that they never happen in El Nino, but they're just a lot fewer and farther between in El Nino than they are in La Nina. But this is for the Atlantic basin. I know obviously there's a lot of question about landfalls. And so this is looking at the the landfall locations for the 15 years with the strongest La Nina conditions since 1950. And you can see obviously a lot of landfalls, 31 at hurricane strength, 10 at major hurricane strength. And if we look at the same analysis, but then do this for the 15 strongest El Nino years, and you look at the dots, obviously there's a lot fewer dots, right? And especially the reds and the blues really drop out, not so much the named storms or the weaker tropical storms. And this makes sense, again, because El Nino really tends to throttle your stronger storm activity. But you do see obviously a lot fewer major hurricanes. So it went from 10 in the 15 strongest La Nina to 3 in the 15 strongest El Nino. But obviously, it's also informative to look at where these storms form. So this is in the La Nina year, so you can kind of see where these storms form. And you can see there's obviously a fair number in the Gulf, but then obviously there's a lot in the Caribbean, the eastern and central tropical Atlantic, and you can see that the kind of the warmer colors, so the blues and the reds, or the stronger storms tend to form more preferentially in the deep tropics. And then it's interesting to look and see, okay, what happens with the El Nino formations? And if we keep your eyes on that 20-degree north latitude line and look at the storms forming in the El Ninos, they pretty much all drop out south of 20. There's not many south of 20. And again, that makes sense because that's where El Nino tends to have your strongest impacts as storms forming in the deep tropics. You see quite a few still in the Gulf, and obviously this year, very, very likely, it's going to be one of the strongest El Nino events since 1950, and we'll probably have a green dot right off the Texas coast because Arthur is looking like it'll probably make landfall just in a few more hours as a weak tropical storm along the Texas coastline. And this also dovetails nicely to my next slide. It's a good example of the odds of storms making landfall in various phases. And so you can see, obviously, for named storms, it's very high likelihood that you get one or more named storm landfalls in any year. And certainly Arthur looks like it's ticketed to be the first storm of the year, the first landfall of the year. So you can check it off the list that we had a landfalling storm. So it's very unusual to go an entire year without one, at least tropical storm hitting the continental U.S. The last time that occurred was all the way back in 1990. But if you look at hurricanes and major hurricanes, you see a significant drop off in the El Nino relative to the La Nina, again, highlighting how for the stronger the storms, the more El Nino has the more significant impact. So for hurricanes, it goes from about a 90% chance all the way down to nearly like a 50-50 shot. Major hurricanes also from about 1 in 4 to 1 in 2. And we can see these similar kind of probability distributions both for Florida landfalling storms. So for example, major hurricanes goes from about a 1 in 4 shot to 1 in 8 shot. Similarly, if we look at Texas, and we're going to throw in Louisiana combined, just to kind of increase the sample size, you'll see similar kind of like 2-to-1 ratios for hurricane and major hurricane landfalls in Texas and Louisiana, whereas for named storms, there's not that much difference. And obviously, again, looking very likely that we're going to have a Texas landfalling weak tropical storm here, later today or maybe early tomorrow. As I mentioned before, the Atlantic is kind of tepid right now, a little bit warm in the west, a little bit cold in the east. You see a lot of cold in the far North Atlantic. There's been some discussion about a weaker Atlantic meridional overturning circulation or kind of deep tropical or deep ocean circulation change, which may have impacts later on in terms of hurricane activity. But overall right now, things are not looking super conducive, even if we didn't have El Nino for the Atlantic. This is kind of showing the current water temperature pattern. This next plot shows the optimal pattern correlation for a busy hurricane season. And you see, the East Atlantic, off the west coast of the Iberian Peninsula, you typically, for busy seasons, you want it to be warm. Whereas if we look back, kind of what we have right now, again, I'd say it's somewhat of a mixed bag, right? We have a little warmth in the West Atlantic, a little bit of cold in the East Atlantic, somewhat warm off of Iberia, but overall this pattern, is kind of a mixed bag, not strongly pointing one way or the other, but given, again, how robust the El Nino looks, it's looking quite likely that we're going to have a pretty quiet overall hurricane season. But obviously, we've already seen with the first storm of the year, not saying we're not going to have any in the way of impacts. The European Center model is forecasting a very robust El Nino, so while the Atlantic is somewhat warm, overall, the shear is forecast to be very, very strong. This model has data going back, so it's been tested on data all the way back to 1981. And if you look at the forecast for shear across that main development region in September, it's forecasting the second highest September shear on record, going back to 81. Only one with higher shear was 2015. So we use a lot of different techniques to come up with our forecast. One is a statistical model, and the statistical model is based on data up through the date of the forecast. So, for example, the forecast that we issue in early June, we have data up through the end of May. And this is kind of the way Bill Gray would have done these forecasts back in the day. You always start with, okay, we only have data up through May. Let's see what basically what kind of precursor signals are there in April and May to tip us off to a busy or quieter season. And you can see overall the forecast model does a reasonably good job. The blue is the observed values, the red is the hindcast values. Certainly there are some years where the forecast busts. A couple of reasons for that. One, what goes on in May is not a guarantee of what's going to happen during the season. And even if you have perfect knowledge of the water temperatures and the shear during the hurricane season, we know that hurricanes are weather events. We're kind of forecasting them on climate timescales. So we know, for example, higher shear average across the main development region and colder waters in the Atlantic are going to make for a quieter season in general. But you could still have kind of individual daily weather events where, the shear may happen to drop for a few days and the storm just finds that one pocket of low shear, or vice versa, where you have very low shear and the storm happens to find the one pocket of region that has higher shear, or the storm happens to track over land. There's all sorts of these things. So the large scale environment only gives you so much information about the upcoming hurricane season. But overall, if we look at the damage from storms, we do see a significant upward shift in the damage when we look at the busy seasons versus the quiet seasons. Certainly there is some overlap. So obviously you can have a very busy season like 2010 where we had 12 hurricanes in the Atlantic Ocean and not one hit the U.S. That's a really good streak of luck, given on average about 30% of all hurricanes in the Atlantic Basin make landfall in the continental U.S. at hurricane strength. But overall, you do see that, when we're forecasting a busier season versus a quiet season, it does shift that distribution of the damage somewhat. But obviously, the forecast for the number of storms or number of hurricanes isn't perfect. That doesn't tell you the exact number that are going to make landfall. And even if you know that 2 hurricanes are going to make landfall, if we don't know where they're going to make landfall, it only tells you so much about the damage and the fatalities, because obviously, as I learned as a geography major as an undergraduate, it's all about location, 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 right? If a storm makes landfall in a densely populated area, it's going to cause a lot more damage than if that storm were to make landfall in a much more sparsely populated area. But overall, a busier season does tend to load the dice, so to speak, towards more damage. We also now use statistical dynamical model forecasts, and that's kind of a mouthful. Well, basically what we use are climate models to forecast water temperatures in the Atlantic and in the Pacific Ocean for the peak of the hurricane season. So as you might expect, a warmer Atlantic and a colder Pacific tends to favor a busier hurricane season. And we use 4 different climate models for these forecasts. We use the European Center model, the UK Met Office model, which is obviously out of the United Kingdom, the JMA model, which is out of Japan, and then the CMCC model, which is out of Italy. And all 4 of these models do a reasonably good job of helping to kind of give us some additional information about the upcoming hurricane season. And you might be wondering, why are you plotting the data from 1993 to 2016? That seems oddly specific and kind of a weird period. The reason why is because that's where we have the data available from all of these different models. Some of these models, unfortunately, when they launch a new version, don't necessarily have the last few years of the hindcast available for us to download. So that's why we're kind of comparing over this, what seems like a somewhat arbitrary period. Like all the cool kids, we also are using AI. This is the ACE2 model. And so unfortunately, it's a little confusing because in this case, we're not talking anything about accumulated cyclone energy. This is the AI Climate Emulator version 2. And so this model has been trained on historical weather data, and it also does a reasonably good job of replicating Atlantic hurricane activity. And so in this case, what we're doing is we're forcing this ACE2 model. We're basically taking it from June 1st and running it forward in time with all 51 of those spaghetti strands, or that ensemble from the European Center that I showed earlier. This model is also calling for very high levels of vertical wind shear across the tropical Atlantic during the peak of the season. So this is kind of a proof of concept that this works. We got a lot more big plans for this ACE2 climate emulator machine learning model that we'll be debuting with our forecast for next year. In addition, we also use analogs. So analogs involves going back into the past and looking for years in the past that had conditions most similar to what we currently see, but especially what we're anticipating for the peak of the season. And so in this case, we're looking for years that had robust, probably really strong El Niño conditions and relatively kind of average, near average Atlantics. So the 6 years that we selected were 1957, 1965, 1987, 1997, 2009, and 2015. These 6 years, all of them had somewhat below normal levels of hurricane activity. Now, when we select these years, we're not saying that we expect to see the storms taking the exact same tracks of those years. For example, 1957 had a Category 4 landfall in Hurricane Audrey, 65 at Hurricane Betsy, which made landfall as a Category 3 near New Orleans. We're just saying overall the conditions look broadly similar over the entire Atlantic, not necessarily for the storms to take specific tracks. That's governed a lot more by day-to-day weather patterns that we just don't have the ability to predict this far in advance. So you can see overall, the final forecast is pretty close to the average of these 6 analog years. We obviously know that these forecasts are uncertain, so we do provide uncertainty ranges around our seasonal forecasts. These are based on the historical error of the models. And so we give you our best estimate. So for example, this year we're forecasting 5 hurricanes, but we do know that these forecasts are uncertain. So kind of a 70% confidence range is somewhere between 3 and 7. This is similar to what you would see in NOAA's seasonal forecasts. The reason why we give you a kind of our best estimate is because at least that way when the media reports on it, they'll report on the number 5 for the number of hurricanes. If you provide a range, say 3 to 7, some media will say up to 7, and then you kind of the high end of your range becomes your actual forecast. So these forecast ranges are fairly large in June. They do shrink somewhat as you go towards July and August because our forecasts get more confident. We also now provide landfall probabilities that are focused on ACE, or that accumulated cyclone energy in the western half of the Atlantic basin. And so the reason why we focus on ACE in the western half of the basin, or wind energy in the western half of the Atlantic, is because that's where people are, that's where property is. And we want to get more towards impact relevant metrics. And we do see that there's a somewhat higher percentage of ACE in the western half of the basin in La Niña than in El Niño. And the reasons for that are twofold. One, in El Niño, we've talked about this before, it really ramps up your shear in the Caribbean. Caribbean, by definition, is west of 60 degrees west, so that knocks down that generation of ACE. But also, storms are a little bit more likely to recurve in El Niño than they are in La Niña. And I'm actually working on a paper with colleagues and hopefully accepted soon that actually kind of highlights the relationship between El Niño, La Niña, and the percentage of storms making landfall anywhere in the North Atlantic. And that's what I want to talk about next, is the relationship between that integrated ACE metric versus North Atlantic landfall. So a lot of time focuses on the continental US, but we know there's a lot more land masses than just the continental US and the North Atlantic. And what we're looking at here is storms making landfall anywhere in the North Atlantic at hurricane strength. The relationship between that and that basin-wide, so basically what we normally forecast as basin-wide ACE metric, and you do see a reasonably good correlation, about 40 to 45% of the variability. But if you up the ante and say, just look at ACE west of 60, you see that best fit, or that kind of that best fit line goes a lot steeper, so indicating a much improved relationship. So we're getting more towards the number of landfalling hurricanes in the North Atlantic. And again, a lot of this is due to the seasonal forecast having best skill in places like the Caribbean, because that's where your El Niño signal is the strongest. That's where your kind of a lot of your wind signals are the strongest. And obviously, if storms are making landfall in the Caribbean, they can have very, very significant impacts. Obviously, just need to go back to last year with Hurricane Melissa making landfall as a Category 5 hurricane in Jamaica. And while the overall $1 billion of this damage may not be nearly as high as in the U.S., can be a much, much higher percentage of their gross domestic product. So what we do is we take those probabilities, or we take the ACE west of 60, which this year is quite low because not only are we forecasting a lower than normal season, we're anticipating a very robust El Niño. So the probabilities this year for landfall are well below their long-term averages. Of course, not zero, but they are well below their long-term averages because we are again anticipating a well below normal hurricane season, and also especially given the strong El Niño, not a lot going on in the Caribbean this year. So you can see these probabilities. These are for broader regions. We also have these probabilities at the state level, as well as the county or parish level if you live in Louisiana, and well as other countries, are basically all the countries in Central America, all the islands in the Caribbean. So if you're interested in these probabilities, you can go and check out our website. We can't forecast the exact number of storms, but we can give you kind of probabilistic information there. Our seasonal forecasts aren't stagnant. We'll update it again on the 8th of July and a final update on the 5th of August. And as I noted at the start of the presentation, even though the 5th of August is 2 months into the hurricane season, about 90 to 95% of your major hurricane activity historically occurs after about that date. So it gives us kind of one final shot to fine tune the numbers, or one shot at a mulligan if we realize we really have messed stuff up till then. But given the robustness of this El Niño, we really aren't anticipating, certainly any significant upgrades in the forecast or increases in the forecast. I also invite you to check out seasonalhurricanepredictions.org. This website is put together by our group at Colorado State, hosted by the Barcelona Supercomputing Center with some funding from AXA, which basically combine seasonal forecasts from all around the globe for the Atlantic Basin. So, we're not the only show in town at CSU. Some of you probably are familiar with NOAA's seasonal forecast, but there's a lot of other groups doing this as well. They include private sector weather companies, government agencies, as well as universities. So I invite you to check out this website if you're interested in seasonal hurricane forecasting. As an example, this is the current visualization from the website. So the y-axis is the red dot is the observed value to date, so we've had no hurricanes. The orange dot is the average of all the different seasonal forecasts to date. And then you can see each of the different forecasts. So the ones that are dots are groups that just give you a round number, whereas the ones that have kind of the lines are the ones that provide error bars, like our forecast at CSU or NOAA's forecast. And they're color coded. So purples are private sector weather companies, blues are government agencies, and greens are universities. So again, I invite you to check out this website if you're interested in seasonal forecasting to get information from all of these different groups and how they're doing their forecast. But you can certainly see this year, pretty much nobody's going high. Everybody's going pretty quiet for this hurricane season. And so with that, I will wrap up my presentation and I'll try to answer any questions. So thanks again for your attention and time today.
Oh, fantastic, Phil. I had two quick questions that came to mind. One is looking at that, how the sea temperature pattern is going in the Atlantic there. I seem to recall somebody did a paper when there's imbalance between like the cooler water in the main development region and warmer water in the subtropics that has an impact. And probably the same issue question, that much warmer water over a large area of the subtropics, would that suggest maybe look for that region for maybe development during the year outside of the MDR?
Yeah, I mean, I think so. And Bill Gray would argue too that, when you look at, say, like the shear impacts, you look at the shear in the tropics and it's a lot higher in El Nino. But further north, when you kind of change the temperature patterns, you actually end up with maybe even a little bit lower than normal shear in the subtropics. Now, normally those storms in the subtropics aren't necessarily super impactful. They may not be very strong, but you would say certainly in this kind of events, you would say you're probably going to see at least a higher percentage of your storms forming kind of from what I would say is like more like non-traditional means. So more like non-tropical lows becoming tropical, honestly, even like an Arthur, which is kind of like a broad area of low pressure, not like a classic forming from a African easterly wave or strong thunderstorm complex. One thing I didn't point out in the presentation, but it's interesting to look at, if you look at the forecast vertical wind shear, say over the next few weeks across the Atlantic, it looks very much like El Nino. Like if you look at the colors of the shear, it's all orange and red. So basically much higher than normal shear across the Caribbean, across the tropical Atlantic. So I think really El Nino is really starting to kind of lock in. You can see a lot of signals for that. So really probably dialing down your Atlantic hurricane season, potentially making for a much more interesting and potentially much more active Eastern North Pacific hurricane season, as well as Western North Pacific typhoon season with longer track storms there. So we're starting to see signs of the Pacific hurricane/typhoon season picking up here too in the next couple of weeks.
Cool. The second question I had is, do you think storms like Arthur that develop in all the wrong reasons, close to land with a lot of shear, do you think those kind of developers kind of put an upper limit on how much skill you can do for a long-range seasonal forecast?
Yeah, and so that's a lot of why we use more like, Bill Gray used to always say, if you're going to get one number right, get the number of hurricanes right. And we forecast the number of storms, but it's really hard to say. You could have a year, and I always point back to my nemesis year, 2013. We had 2 hurricanes that year. We predicted 8 or 9. So it was like predicting the Colorado Rockies to win the World Series last year. Spoiler alert, the Rockies last year were horrible if you don't pay attention to baseball. But when it comes to the number of storms that year at 14. So if you just looked at the number of storms, it was an average season. So you wouldn't have thought anything of it. But, so that's why when we do a forecast for things like that accumulated cyclone energy metric. So a storm like Arthur is going to have very little impact on that number. ACE is kind of a nice metric too, because you can have a kind of a wonky year like last year where, we forecast we had 5 hurricanes last year, which is what we're forecasting now. But of those 5 hurricanes last year, 4 of the 5 reached category 4 strength, 3 were category 5s. So, even the number of hurricanes isn't always a perfect metric, which is why we forecast several metrics. But I think really getting at that ACE metric is somewhat, it's not perfect, but it somewhat gets more at overall basin-wide activity than, say, just like the number of storms. Because like you said, this year we could have very high shear and get 11 or 12 storms if we get a bunch of storms at higher latitudes that are weak and short-lived. But, we may still only have an ACE of, 50, 60, 70 points, something like that. So, yes, I would agree that forecasting the number of storms, because you get these storms forming from kind of bizarre mechanisms and in fairly high shear environments, there's only so much you can do at forecasting that on seasonal timescales.
Hell yeah, it's challenging enough to do it in 24 hours.
Exactly.
Hal, what you got for us?
Yeah, if I'm wobbling around here, man, the wind is just blowing my car. I'm parked on Galveston Seawall. Great presentation, Phil. Phil, I wanted to ask you, when we look at the impacts of El Nino, is that more pronounced when we get into, say, later in the season, like September, October, compared to early in the season? I mean, can you break that down temporally at all?
Yeah, so typically, El Nino really has its strongest impacts later in the season, and that's because vertical wind shear, one, the El Ninos tend to intensify as you go along, but also vertical wind shear is really what kills your season late. Early in the season, it's more too much dust, too much dry air. You hear about like Saharan dust and all that kind of stuff. But late in the season, it's really vertical wind shear, which kills the end of your season. So typically, especially say like October, November, we would expect to be very quiet. And especially, the odds of significant hurricane activity in the Caribbean late this season, probably very, very low, just given we're probably going to have a really robust El Nino. So likely very high levels of shear. So, even if the anomaly or the difference in shear is the same in August, September, and October, because the background shear is so much higher late in the season, it's going to have a much higher impact. So yeah, overall, El Nino tends to have its strongest impacts late in the season. One, because its primary way of modulating the season is shear, and the shear gets stronger later. And also, typically, your El Ninos tend to grow or get stronger with time. So, for example, right now, it's kind of weak to moderate, but by October, it's looking very likely that it'll be strong and perhaps even of the Jurassic variety.
Bill, one other question. What about geographic origin? A storm forming off the Louisiana coast, maybe even the Carolinas in general. Does El Nino impact that less than something in the Western Caribbean?
Yeah, so as higher latitudes, you tend to get less of a modulation from El Nino. And so if we remember back to looking at where the storms make landfall, or where the storms that make landfall in the U.S., where they form, you see a big drop off south of 20 degrees north, so in the Caribbean and further east in the tropical Atlantic. But if you look, say, in the Gulf in situ, there's not that much difference between El Nino and La Nina. Typically, those storms tend to be weaker, so they can be significant rain threats. So Arthur's a great example of what we're looking at. Like kind of a weak storm, potentially a big rain, has been a big rain producer, but not probably a massive wind or storm surge threat. Just because if something forms, in the central or northern Gulf, it takes a little bit of time for a storm to intensify, and even if the conditions are fairly conducive, if it only has one or 2 days over water, it probably can only get so strong. So yeah, as you go kind of poleward of 20 degrees north, the impacts of El Nino and La Nina on tropical cyclone development are just weaker than they are in the deep tropics.
Bill, last question, and then back to Bill and Tim. Rockies, Red Sox, who do you like?
Well, I'm going to the game on Monday, so hopefully the Red Sox will pull it off. I'm wearing the Red Sox hat. My wife Chris will be wearing the Rockies hat. So, but either way, unfortunately, I don't think either of our teams is a playoff. Either the Red Sox or the Rockies are playoff bound in 2026.
Phil, if you would stop sharing, we can all see your full-size face.
Oh man, no one wants to see my full-size face. I did shave this morning, so I look a little less unkempt.
Yeah, me too. I usually refuse to shave half the time in retirement, but I did today. Tim, over to you. What you got?
I just have a couple of last questions for you. Phil, the June forecast is lower numbers than the April forecast. You touched on that briefly. Is that just increased confidence in the El Nino? Is that what creates that? Yeah.
So, in early April, we were thinking probably a decent El Nino, but the last couple of months, things have really trended more robustly towards a really powerful El Nino event. It's obviously, we don't know exactly how powerful, but it's probably going to be one of the at least top 5 of the last 75 years. And you can see that confidence both. We put out our forecast the day before NOAA put out its updated and El Nino forecast. So we had to be very careful with how we word things. But, at that point, it was like, yes, we're pretty much El Nino is here, and it looks like it's going to be quite strong. And they really increased their confidence for a strong El Nino. And you can see kind of in the wind patterns across the Pacific that, it's really locking in pretty quickly. So, there's been some years in the past where El Nino took its time kind of locking in and getting like the atmosphere to respond, but this one looks like it's getting this hurricane season. Another good expression from Yogi might be relevant too. It's getting late early. Maybe anything that's going to go, it better go quick, because it looks like the shear is really going to be ramping up here.
Are you surprised that your coin of Jurassic El Nino went viral when first time you mentioned it?
Well, I've been pushing Jurassic El Nino since 2015. Some have called it Godzilla El Nino. I don't really get the point of Godzilla El Nino, because Godzilla wasn't even in the tropics, so what does he care?
Awesome. Awesome. Terrific presentation today, Phil. We really appreciate it. Great job. Great job. Thank you so much.
Thank you.
We're going to jump back out to Hal for a second out in Galveston. And Hal, have conditions changed out there much since we got started?
Yeah,
what do you think?
It is so windy, Tim. The car's bouncing around. If you have like 15 seconds, I'm going to change the camera angle, and you probably won't be able to hear me at all. But look at this. The sun's actually coming out. Right at the box. That's a live view.
Beautiful.
Yeah, you're right. We can't hear you, but it's a great picture.
Yeah, I just wanted, the rain is actually really past the area. No more real rain threat. And I saw NWS really drop the rain threat for the region. Really, everyone on social media now talking about the winds. We did not expect winds like this, and a pretty big surge coming up on the beach. But again, it'll be pushing out over the next several hours.
Well, and you're only under a tropical storm watch where you are rather than a warning, even though you're just a few miles from the core of the system. Core, if there's such a thing.
Yeah, that's exactly right. It seems like we're definitely getting gusts, I know, in the 40s, maybe even up to close to 50. We had an OBS at Galveston Airport to 47, and I am hearing reports that people even on the island now losing power. So in general, we're not really expecting that. So the wind is really outperforming what we were expecting. We talked about before the rainfall very localized. If you got hit, a lot of places did get hit hard.
Well, the history of the system as it moved over our part of Texas, South Texas, was 8 to 10 inches of rain. So, yeah, that was when it was over land. So, yeah, pretty soon. Very quickly, Hal, do you have a geotrick thing you want to tell us about this week before we let you go?
You know what? I'm going to be away from NTWC for the next week or two because I'm going to be in El Salvador, actually. We're launching a documentary series where we're going around the world to really cover those stories about extreme weather, natural disasters, and how we can be more resilient. So this documentary series will be called Extreme Explorations, Episode 1, El Salvador, Episode 2, Colorado, U.S. states, our regions we're doing with this. And we're going to learn a lot, and it's going to be really interesting. So we'll keep you updated here at NTWC with GeoTrek's Extreme Exploration documentaries.
Can't wait to see what you do. Thanks. And thanks for being with us today. And thanks for going out on the edge of the world there to let us know what's happening.
Thanks so much. And great job, Phil.
We appreciate it. Thank you. Thank you, Al. Bill, last thoughts before we let Phil take off?
It's fantastic having you on with us, Phil. I learn something every time you give a talk for us.
Thanks so much. It's been great as always. And I'll look forward to speaking with all of you gentlemen again here at some point in the next, not in the not too distant future.
Absolutely. We'll have you back on. We want to thank you, Phil, for being with us. Dr. Phil Klotzbach, our guest today from Colorado State University. Always a terrific program. Thank you, Phil. We appreciate it. Thanks for Hurricane Hal for joining us on the Galveston Seawall. Bill Reed for joining us from Tahiti, wherever you may be, somewhere in New Mexico. Thanks to our sponsors, USAA, the South Padre Island Convention and Visitors Bureau, Live View, and the Texas Weather Network, all folks that help make these programs a reality week in and week out. Next week, Mike Lowry joins us. If you know Mike, you know it's going to be a great program. He really kind of cuts to the chase on tropical stuff and provides a great insight as to what's coming in the near future. So join us next week as Mike Lowry is with us. For today, thanks for hanging out with us. That's NTWC Plus. We'll see you next week.